Hello everyone, and welcome to the next video in the series. This is a technical skills video, and the topic for this video is multiplication and division of integers. Just a reminder that the set of integers Z is the set that contains numbers like -3, -2, -1, 0, 1, 2, 3, and so on. Now, as far as multiplication and division go, a brief comment on notation. When we have two positive numbers, we could of course use the x notation for multiplication and write 4 times 5. And even if the first number is negative, we can still write -4 times 5 without the use of brackets. However, if the second number is negative, then this notation is not very useful to us later. It can cause a lot of confusion, as you see in the next video when we talk about expressions where we have addition, subtraction, multiplication, division, as well as positive, negative numbers, because then the negative sign becomes confusing. The negative sign and the subtraction sign, it becomes confusing. It becomes difficult for us to tell at a glance whether we're dealing with a sign or whether we are dealing with a subtraction. So a better notation is to use brackets around the second number in case it's negative, and so we prefer to write 4 times -5 this way. And of course this has to do with the second number being negative. The first number could be positive or negative, and again, it doesn't matter. We still don't like this notation where we use the times notation with a negative number without the use of brackets. And a better notation here as well is to put -5 inside brackets like this. If you have more than two numbers that you are multiplying, then so long as all the numbers other than the first one are positive, the use of the times notation is okay. But if even one of the numbers other than the first one, even if one of those is negative, then we prefer to use brackets throughout. So we write -4 times 5 times -7 with 5 and -7 inside brackets. One thing that you should definitely stay away from is to use mixed notation. This becomes pretty annoying and confusing to read when we write -4 times 5 bracket -7. It leaves somehow the impression that 5 times -7 is grouped in a special way, or maybe some people see -4 and 5 as being grouped in a special way. And that sort of breaks into the continuity of the chain. So we don't like that kind of notation. Okay, multiplication and division. We take a couple of cases. One is when we multiply or divide two integers, and there are 4 cases. Both are positive, so we have positive times positive. We have positive times negative, negative times positive, and negative times negative. And all of these, the way we work them out, the rules that we have for evaluating them have semantic roots, and these roots are that multiplication and division, or division of integers that have the same sign, both are positive or both are negative, generates a positive number, and multiplication or division of integers with different signs, so one is positive, the other one is negative, generates a negative number. So examples of this, we're going to go through the 4 problems that we have up here. The first one, of course, is 4 times 5, which we all recognize as 20. The second one, 4 times -5 is equal to -20. And to see why it is that a positive number times a negative number turns out to be negative, we can think of a practical problem where you owe $5 to each of 4 people. So in total you owe $20. And when we think along those lines, it does make sense that a positive number times a negative number should be negative. Again, interpreting the minus sign here for this problem as what you owe. If you owe $5 to each of 4 people, then in total you owe $20. So the O part is the negative sign. And the negative times the other case, the other case where we have negative 4 times 5 is also negative. And this one also, you can think of it as owing $4 to each of 5 people. And so in total you owe $20. Again, you notice that negative times positive is negative. And the last case is negative 4 times negative 5 equals positive 20. Now for this one, for a moment, ignore the negative sign at the very beginning and think of this as 4 times negative 5. So you owe $5 to each of 4 people. And then you forgive the money that you owe to all of these people. So in total, your worth grows by $20. And the case for division is the same. Division is the opposite of multiplication, of course. And so positive divided by positive is positive. Positive divided by negative is negative. Negative divided by positive is negative. And negative divided by negative is positive. So again, if the two numbers have the same sign, we get positive. If they have different signs, we get negative. Now the algorithm for working at these problems is that you work at the sign first and then you work at the magnitude. And this becomes important in the next video when we talk about expressions. It will help a lot in simplifying your expressions pretty quickly and with confidence. And so what we do is we work out the sign. We notice here that, for example, 4 times 5, this is positive times positive, same signs. And this is negative times negative, which is also the same signs. Incidentally, you can think of this as having an even number of negatives, and that gives you a positive number. If you have one negative, which is an odd number of negatives, then you get a negative number, negative answer for it. And the same is true for division. So if you have zero negative signs, or if you have 2 of them, an even number of them, then the answer is positive. And if you have an odd number of negatives, such as 1 of them, then the answer will become negative. So we work out the sign and then we work out the magnitude. If I was going to work out 20 divided by negative 4, I would first argue that it will be negative, and then I would divide 20 by 4. And once I've worked out the sign, I don't have to worry about the sign anymore. I just divide 20 by 4 and I get 5. So step 1 is to work out the sign, and then step 2, you ignore the signs now, and then you work out the magnitude. Now if you have a chain multiplication division of integers, we can sort of combine the rules that we have above to come up with the following two. An even number of negatives generates a positive result. An odd number of negatives generates a negative result. So for example, if I'm multiplying, let's say, 3 numbers, and there are 2 negative numbers in there, that's an even number of negatives. The answer will be positive. Basically, if you have 2 negatives, they cancel out based on the rule that we have for multiplication of 2 negatives, which was up here. 2 negatives will generate a positive. And so if you have, let's say, 2 of them, or 4 of them, or 6 of them, or an even number of them, 2 by 2, they would generate a positive number, and the answer will be positive. If you have an odd number of negatives, then 2 by 2 they cancel out, and 1 of them stays. And here's an example of such a problem. We have 5 times negative 2 times 3. So as usual, we work out the sign, we work out the magnitude. Sign-wise, there is only 1 negative. That's odd. So the answer will be negative. And we write the sign down. Once we have worked out the sign, then we ignore the sign and we multiply 5 by 2 by 3. 5 times 2 is 10. 10 times 3 is 30. And now we write negative 30. You notice that this is much more efficient than, let's say, BEDMAS, where we go from left to right. And then we have to argue, if we follow 2 at a time, we have to argue that positive times negative is negative, and then 5 times 2 is 10, and so we have negative 10. And then negative times positive is negative, and 10 times 3 is 30, so we get negative 30. There is a lot of thinking involved in that, and the longer the chain, the worse it becomes. Whereas this approach that we have here is much more efficient. First you count the number of negatives. There is only 1. That's odd, so the answer will be negative. Now ignore all the negatives and multiply 5 by 2 by 3 to get 30. Here's another one. same size numbers, but now we have negative 5 to begin with. So we have negative 5 times negative 2 times 3. We work out the sign first. There are two negatives. That's even. So the answer will be positive. Now normally we don't write the positive down, but I'm going to write it down just for emphasis, that you work out the sign first. And then once you've worked out the sign, then you can ignore the signs. And then you multiply 5 by 2 by 3 to end up with positive 30. And here's a third example. Now all three of them are negative. And we work out the sign. There are 3 negatives in total. That's odd. So the answer will be negative. And we write the negative sign. And then once we have worked out the sign, now we ignore the signs. We multiply 5 by 2 by 3. And that gives us 30. So the answer is negative 30. And the rules stay the same if you have division, and I don't know why I have the word division typed twice here. Let's get rid of 1. There we go. So the rules remain the same if division is present. Here's an example. We have negative 14 times negative 15 divided by 2 times negative 5. And here we can see this as a chain multiplication division. You notice, this is important, that there are no additions or subtractions anywhere in this expression. That's important because the rules that we have above in terms of work out the sign, work out the magnitude that we just talked about, they apply to multiplication and division. In the previous video, we talked about rules that apply to additions and subtractions of positive, negative numbers. So here, first we note again that there are no additions or subtractions, and then we count the number of negatives. We have 1, 2, 3 negatives. So the answer will be negative. And then we multiply 14 by 15 and divide by 2 and then 5. And we get 21. Okay, so now we have talked about the multiplication and division of integers, but one thing that I would like to talk about, this is a good time actually to talk about this, and this is that if just as if you subtract a sum, you can do individual subtractions. So if you're subtracting, doesn't matter what the first number is, let's say 100, let's say. And let's say that you bought something for $3, you bought something for $2, and you bought something for $7, and you want to find out how much money you have left. You can subtract the sum of your expenses like this, or you can subtract each expense individually. So you can subtract 3 and then subtract 2 and then subtract 7. This rule is something that most people are familiar with, but one that also exists, the same kind of relationship that exists between multiplication and division, is one that most people are not aware of, and this is actually a very important kind of relationship to know. We will rely on this understanding quite frequently in the videos ahead, and this rule is that if you are multiplying and dividing, you can actually, let me see if I missed one image. Yes, if you're multiplying by product, then you can divide by each of the factors individually. Again, let's take a look at, compare this to the problem, to the subtraction problem. You subtract a sum, and here you divide by a product. And just as subtracting a sum is the same as individual subtractions, dividing by a product is the same as individual divisions. Now I will have more to say about this in the videos ahead, but one way to explain why this is the case is if we think of dividing, let's say, 1 pie into, let's say, 6 parts. So let's say that you have a pie and there are 6 kids, and you want to divide the pie into 6 parts, 1 for each kid. Now the way you would normally do this, I hope, is to first cut the pie in half, so you don't sort of try to estimate at 1/6, although you can do that too. But another way anyways of doing it would be to first divide the pie into 2 parts, and then you take half and then you divide each half into 3 parts, and that would be the same as doing the division, or thinking of the division as being 1 divided by not 6 but 2 times 3. So you notice that 6 is the same as 2 times 3, and this would be the same as 1 divided by 2 and then divided by 3. Same thing here. If you divide by 3 times 2 times 7, you divide by 3, you divide by 2, you divide by 7. If you divide by 2 times 3, which is divided into 6 parts, then you can divide 1 by 2, take the answer, and then divide by 3. So this expression is the same as 1, then divided by 2, and then divided by 3. Okay, so again, dividing into 6 parts, or 2 times 3 parts, is the same as 1 pi divided into 2 parts, and then you take that half and divide it into 3 parts. Now, this is interpretation of division by a product. We can also talk about when we have numbers on the top. So if you have 18 times 14 divided by 3 times 2 times 7, the proper way to look at this is 18 at the top multiplied by 14, of course, and then you divide by 3, you divide by 2, and you divide by 7. It is, of course, possible to multiply 3 and 2 and 7 and then divide by the product, but it's important to understand that this is another way of doing it, and this other way of doing it sometimes becomes pretty much key to understanding some of the concepts that we will be talking about later on. Now, as far as performing the multiplication division chain goes, let's start this with 1 times. So now we have 1 times 18 times 14 divided by 3 divided by 2 divided by 7. And I say 1 times. It's similar to when we talked about additions and subtractions, and we said you can start a chain addition subtraction with 0 plus or 0 minus. For multiplication division, it will be 1 times or 1 divided by. So this expression, you can always think of it as having a leading 1 times or 1 divided by, depending on whether you're multiplying or dividing by the number that follows. Now, what's interesting is that you can do these multiplications and divisions in any order. You can actually try it on the calculator very quickly to see that, for example, the sequence that we have here is the same as the sequence 1 times 14 divided by 2 divided by 7 times 18 divided by 3. Now, if you take a look, you notice that here I multiply by 18, and down here I do the same, times 18. With the first expression, we multiply by 14, and here we multiply by 14. Divide by 3, same thing here, divide by 3. Divide by 2, and again we have divide by 2. And then we have divide by 7, and we have divide by 7. So long as whatever you multiply by in the first expression is the same as what you multiply by in the second expression, it doesn't matter whether you do it earlier or later. Here's a third one that starts with division. I could actually start with 1 divided by 2. And here's the third one, 1 divided by 7, divide by 2, times 14, divide by 3, times 18. And you notice that I have divide by 7, divide by 7, divide by 2, divide by 2, and so on. So if I'm working out a problem like 18 times 14 divided by 3 times 2 times 7, let's say I'm working on a calculator. Then what I can do is I can quickly type 18 times 14 divided by 3 divided by 2 divided by 7, and then equals. And here's how that would work. Okay, so on this calculator, I'm going to type 18 and then times 14, and then I'm going to divide by, that would be this button. So divide by 3, I'm following the sequence here. Then divide by 2, so divide by 2, and then divide by 7. Divide by 7. And the answer will be 6. Now remember that, the answer is 6. Now I'm going to clear this, and I'm going to do the last one, the last sequence. So 1, divide by 7, so we are here now, and then divide by 2, and then times 14, times 14, and then divide by 3, and then times 18, and we are back to 6. Magic. All right. Okay, so now we have covered multiplication and division of integers, and in the next video I will be talking about expressions where we have a mix of addition, subtraction, multiplication, and division. And for now, again, I will be gone in 3, 2, and 1.